Hi again. Let's do the liver. So lots of metabolism occurs in the liver, many metabolic functions. Detoxification of drugs and alcohol occurs in the liver. Glucose, remember, glycogen is stored in the liver. The liver also is responsible for deamination of amino acids, which is where you remove the amine group from the amino acid, convert that to urea. So the amine group was the NH2 group from the amino acids. That gets converted to urea. That goes into the urine and then is removed by the kidneys as urea. Hepatocytes for the liver. Cells of the liver, they produce bile, which we'll talk about. That drains to the gallbladder and then into the small intestine. So we'll take a look at bile. And then we'll take a look at the hepatic portal system. So, liver and blood flow. So this, I would like you to pay attention to and be able to sketch it. I really want you to understand the blood flow to and from the liver. So there are a couple of blood vessels to pay attention to. There's the common hepatic artery, the hepatic portal vein, and then hepatic veins. So maybe we should make that plural. Turns out there are multiple lobes, so it turns out there are multiple veins. Not a big deal. If you just remember it as singular, you'll be okay. So let's start over on the figure with the figure on the right. And here, of course, is the aorta. So this would be good practice to trace a drop of blood from the heart to the liver and do the circulation. So notice that there are two blood flows going into the liver. The first one is hepatic artery. So right here would be our celiac trunk, where we have a common hepatic artery. Okay, so this is taking oxygenated blood directly into the liver. And then there are a series of capillaries in the liver. That is where all of the metabolism occurs. So that's one flow. Freshly oxygenated blood going into the liver and pooling in these large sinusoid-like capillaries. The other blood flow to the liver is coming from the intestines. So the small print here, if you can read that, you may have to enlarge it on your computer, zoom in, but it's capillaries of the digestive tract, stomach, intestines, pancreas, spleen, etc. So this is coming from the digestive system. So it's carrying nutrient-rich, oxygen-poor blood. Nutrient-rich, O2 poor. The blood has already been through one set of capillaries. And then the blood leaves those capillaries to this hepatic portal vein and goes back into the liver again. So again, if you can't read that small print here, this is the hepatic portal. Vein. So you recall that a portal vein connects two capillary beds. So the first one is, here is our primary capillary bed, and then our secondary capillary bed. And the portal vein connects the two together, which is an unusual arrangement. Normally there's this one bed of capillaries. You have an artery supplying it and a vein draining it. And then it goes back to the right side of the heart to get reoxygenated. But in a portal system, a portal vein connects two capillary beds together. First one in the intestines, digestive system. Second capillary bed is in the liver. Okay, so, and then draining the liver is the hepatic vein. So you have to be clear on hepatic artery, hepatic vein, and then the hepatic portal vein. So let's take a look at the illustration on the left. So these are major blood vessels of the portal system. So the players over here are the spleen, which is this brown football looking affair, and then the liver, and then the intestines. So here is the small intestine coming from the small intestine, and here is coming from the large intestine. So the blue is the system of veins. The red is the arterial blood flow. So let's do the arterial blood flow for just a moment. Here is the blood coming from the aorta. So that, again, is our celiac trunk. Okay, so you're oriented. That little circle. And we have a splenic artery supplying arterial blood to the spleen. And we have arterial blood being supplied to the liver through this hepatic artery system. Off of the celiac trunk, it's the common hepatic artery, which then branches into the two major lobes of the liver. And we have the right and left hepatic branches of the artery. Well, the hepatic portal system is really what I want to focus on here. So the blue sort of looks like a chair. So if I can make a mess out of the drawing here and just sort of attempt to draw a person sitting in the chair, let's make them a green person, I don't know. There's the head, I'll erase this in a moment. And then neck, and then here's the rest of him or her, sort of hanging out on the easy chair. And then the legs going up over the footrest, and then here's a foot, not bad, kneecap, and there's another foot doing the same, and then, you know, he's got some arms. But anyway, that's kind of how it looks. So the point is, it sort of looks like a chair. So you have one leg, which is the superior mesenteric vein, another leg, which is the inferior mesenteric vein, and then all of this is the splenic vein. And then we have the hepatic portal vein, which is the back of the chair. So if you kind of start thinking in terms of that chair, it helps to make sense. In the next slides that we look at, we'll continue on with that. So again, the superior mesenteric vein from the small intestines, the inferior mesenteric vein from the large intestines, and then all of this splenic vein, all the way from the spleen to this junction point here. And this is all going to be, this green is splenic vein. And over here, it's still the splenic vein on the right. And the splenic vein first merges with the inferior mesenteric, and that merges right here. So as the inferior mesenteric merges with the splenic, that's the end of the inferior mesenteric. The splenic vein continues, and then the superior mesenteric vein merges with the splenic vein right there. And from this point on, from that red line into the liver, is the hepatic portal vein. And it's again printed in the diagram, but I'm not sure if it's large enough for you to read. So it will help you if you know where these arteries end and the name. The tricky part perhaps is that this is the splenic vein all the way through to the point that it merges with the superior mesenteric. Okay, let's move on. Practice that. Draw it, sketch it, label it. And then look at other diagrams and find those arteries and veins. We'll practice that in a little bit. But first, let's take a look at sort of a functional unit of the liver. And this is a lobule. Small lobe, if you will, of the liver. And notice there are some things to pay attention to. There sometimes sort of these little polygon-shaped lobules, and on the corners are these portal triads. So there's one, and a portal triad, as printed at the bottom, consists of a branch of the hepatic artery, a branch of the hepatic portal vein, and a bile duct, or ductule is just a small duct. So there's one triad, and here's another one, and they're at the corners. And so you have those three things together, and these are the triads, etc. So the blood flow is coming in through the hepatic portal system, the hepatic portal vein. So this is a branch of it. It's coming from the intestines, from the spleen, from the stomach, from the digestive system, and it's flowing into the liver, where it gets processed. And the little brown hepatocytes do all of that amazing metabolism. So if we just follow one of these triads, this one on the left, the blood flows in. It's nutrient rich, oxygen poor, and then it branches out, and then it starts to go into these tiny little veins. And notice that it's also mixing now with oxygen-rich blood that's coming in from a branch of the hepatic artery, and that oxygen-rich blood then goes off also and mixes, so delivers oxygen to the hepatocytes that are very energy intensive. They require a lot of oxygen to do the metabolism, all of it which requires lots of energy. So the blood then processes through and eventually works its way through this system out of these capillaries, these sinusoid capillaries, into the central vein. Leaves the center of this lobule and then flows out and merges with other veins, and then those ultimately drain off and go into the hepatic vein and leave the liver. and ultimately off back to the inferior vena cava. So that's the basic blood flow. The hepatocytes, if you could zoom in on this, would help. But the other thing to note is the bile that's produced. So here is a bile duct, the green, and it's a little hard to see in this figure because it needs to be magnified a little bit. But the blood is on one side, over here on the right. So the blood is in the blue, and then the nutrients are absorbed by the brown hepatocytes through various transport processes into the little brown hepatocytes, and then those then exocytose bile into these little green dots, which are these little tubes. And so here's a system of these bile canals that the hepatocytes exocytose bile into, on the opposite side of the blood flow. And then that bile then flows through these little canals, and ultimately, you switch colors and go back to this bile duct. The bile then is flowing in this direction. So all the little hepatocytes then drain into the bile ducts, and then this ultimately leaves the liver and will be stored in the gallbladder. Okay, next slide talks a little bit about bile. Two different images. They're at the bottom. They're trying to show similar ideas. Again, bile is produced in the liver, stored in the gallbladder, and bile includes a mixture of different substances, including bilirubin. We talked about that very early in the class. Breakdown product of red blood cells, and different bile acids or bile salts. The terms can be used more or less interchangeably. And those are made from cholesterol. And one of the main functions of bile, in addition to getting rid of various wastes like bilirubin, is also to help emulsify fats into smaller droplets, which increases the surface area for lipase action. So emulsifying is not the same as dissolving. Emulsifying is where you take a mixture and you break it up into smaller little droplets, and then those stay suspended in a liquid. So we're talking about digestion of lipids. They go into a watery environment. They become emulsified. They do not dissolve like salt does or sugar. These are hydrophobic, non-polar lipids. They don't mix well with water. So if you're going to move them through a watery environment and break them up and digest them, bile is necessary for that. So here's basically the idea. And these, they sort of, as drawn, I'm over here on the left portion, the green, as they're drawn, they sort of look like little phospholipid molecules. You remember that when we were drawing phospholipids, we had a polar head and then two nonpolar tails. The same idea. These aren't necessarily phospholipids, but the idea is the same. So let's go over to the right side, the right lower figure, where an artist just drew it a little bit differently. And what they've drawn is one bile acid or one bile salt, one of these little guys, is what they're drawing over here, just a different way of showing that. And what they're showing is that there is a hydrophobic side and a hydrophilic side. This is just a cartoon sketch. Hydrophilic. And the other side, if you can't read the small print, is hydrophobic. And so what happens is that you use these bile salts, these bile acids, and here is a lipid molecule. So it is non-water soluble, so it's hydrophobic, as lipids tend to be. And what you do is that you coat it with these bile salts, these bile acids, and the hydrophobic side in yellow associates with the hydrophobic lipid, and they get stuck together. And so pretty soon this blob of fat, this large lipid droplet, is coated with these bile salts, these bile acids that become, they coat it, and then this portion, the green, interacts with the water. And hydrophilic, let's say, interacts, bonds with, perhaps interacts with water. And now you have emulsified the fat. It is not dissolved, but it's suspended in the water. And then you can move it along through a watery environment, through the blood, through the lumen of the intestines, etc. And so what happens, back to the figure on the left now, there's a green amoeboid looking clump of lipid. So this is our lipid, and it's we went to a pig roast, let's pretend, and it's a big blob of fat we ingested. Well, that's got to be broken up into smaller droplets, which will increase the surface area, which makes it more efficient for the lipases. So the bile salts have taken this mass of lipid and broken it up into smaller little droplets. And as you go from one big blob to one smaller, numerous smaller little droplets, we wind up with an increased total surface area. The volume gets smaller, but the total surface area of all of these taken together increases. And we're actually measuring the surface area of the lipid. And then that just makes it more efficient for the lipases to digest the fat, the lipid. Okay, let's get rid of this, those drawings. So here's the plumbing of the bile system and the gallbladder connecting to the small intestine that I would like you to be familiar with. So here are the hepatic ducts, if you can't read that again. Two main lobes of the liver, the right and the left. So this is the left as drawn and the right. And those are carrying bile from the hepatocytes. So the bile is entering through these hepatic ducts, a right and left hepatic duct. Those then merge, and then we have a larger common hepatic duct. Which again is indicated in the picture, but I'll write it larger. And then that bile, then, as it's being produced, will then travel up through the cystic duct into the gallbladder. So this, again, as drawn, is the cystic duct. I don't care about the smooth and spiral portion of that cystic duct. And the bile is stored in the gallbladder, and it's also concentrated. So let's say stored and concentrated. Much of the water is just removed. So once the signals for fat digestion reach the system and the gallbladder is stimulated to excrete bile, the bile then is pumped out of the gallbladder back through the cystic duct, and now it flows down into the common bile duct. And then it eventually leaves out to this ampule. So this is the, again as drawn and labeled, is the common bile duct. So you have to pay attention to the names. You don't just call it a bile duct or a hepatic. You could call it the bile duct, but it goes oftentimes by the common bile duct. Probably more, an easier place to get messed up would be just between the hepatic ducts and the common hepatic duct. Common, again, is referring to a branch. So that's the route of the bile, and it exits through this pancreatic, or it merges with the pancreatic duct, which is here. Again, if you can't read this, pancreatic duct, and then they exit together through this common hepatopancreatic ampulla into the duodenum. So look at the drawings or the illustrations that aren't all corrupted with my red and yellow ink in that slide set that I gave you. So practice drawing that system of the bile plumbing and merging with the pancreatic duct. Okay, so I want to spend some time going back and reviewing the hepatic portal system and talk about esophageal varices. So before we get started, first of all, looking at the figure on the right, can you find that chair that I was illustrating earlier? Can you find the two legs and the footrest and the back of the chair? to get yourself oriented again? Well, here is one leg of the chair. And here is the other leg of the chair. And they both end right there. And the larger one that's connected to the back was the superior mesenteric. Vein. Abbreviate superior and maybe we better spell this out. Mesenteric vein. And over on this side, oh, and notice that the superior mesenteric vein is supplying blood to all of the small intestines. So here is the duodenum. So this is small intestine. There's the duodenum, and that flows into the jejunum, and then the ileum. So this is representing all the small intestines, and then into the large intestine. So all of that's being drained by the superior mesenteric vein, as well as the ascending colon and part of the transverse colon is being drained by the superior mesenteric. The inferior mesenteric the other leg of the chair is draining blood from the lower portion of the digestive system, the alimentary canal. So sigmoid colon, descending, and the other portion of the transverse. Okay, so back to the hepatic portal system. Here is the splenic vein again, draining the spleen. And again, it merges with the inferior mesenteric vein, merges with the splenic vein. The splenic vein continues on and then merges with the superior mesenteric. And then where the superior mesenteric and the splenic vein merge, we then have the portal vein, hepatic portal. Okay, so now the stomach and the esophagus also drain into the portal system. So the diagram doesn't show it well, but here is the esophagus. Continuing on, so there's the esophagus. It's hidden behind the liver. But I think you can still see that as it drains in, as it moves into the stomach, there are veins on the esophagus that I'm sort of outlining in yellow, and part of the stomach, but there are also veins on the superior portion of the esophagus as well. So those veins on the esophagus then drain into this portal system also, merging with blood from the stomach. Many anastomoses, but they also drain into the hepatic portal vein. Okay, so that's important to remember. Now, when if the liver is damaged from, well, lots of different things can damage the liver, unfortunately, but cirrhosis from various causes, which is scarring of the liver. But cirrhosis can be caused by chronic alcoholism or hepatitis, or drug toxicities can damage the liver. If that happens and the blood flow through that liver becomes blocked, those little lobules that we looked at before are destroyed and replaced with either scarred tissue or fatty tissue, then you start to lose that functional capacity of the liver and the ability of the blood to flow through the liver and out of the liver back through into the inferior vena cava. So the liver blocks up the blood flow. The blood, all of this blood from the digestive system that would be normally flowing through the hepatic portal system, through the liver and out of the liver, gets backed up. So we wind up with portal hypertension. Blood pressure in the hepatic portal vein becomes elevated because the blood can't leave through the liver. It backs up. That backs the blood up everywhere else. And one place that it backs it up is into these esophageal veins. And then those veins become varicose. They swell up and the blood vessels dilate, just like varicose veins in the lower leg, where the circulation may be poor, the valves get blown out, and the blood starts to pool. Well, these esophageal varices are very close to the lumen of the esophagus. So if I can draw in the bottom picture, I used to have a slide that showed one of these things bleeding, but I lost it at some point. So let's pretend that this is a cross section of the esophagus. And here is the lumen of the esophagus. And then there is lots of muscle, of course, that goes around. And there is a blood supply, and then you have these esophageal veins. And the veins are very close to the lumen. So I'm going to label those as esophageal veins. And what can happen is that with this hypertension and the varices, which is plural for varicose veins, the varices then leak and they blow out, and then you start to bleed directly into the lumen of the esophagus. And that can be a significant source of blood loss, and there's very little ability to stop the bleeding. You can't practically go down the esophagus and put direct pressure on it. You're not fixing anything. There's still hypertension. If one blows out, another one may start to leak and blow out also. So this is life-threatening, and people can bleed to death through esophageal varice bleeding. It's another example of a rather miserable pathological demise. liver failure. So I hope that makes sense on what these esophageal varices are, how they form, and why they're important. And the last slide is just, I just threw it in for review again. Shows a couple of things. One is that it shows the falciform ligament, which is what separates the two lobes of the kidney and anchors it to the diaphragm. Falciform ligament, and then see if you can identify this hepatic portal system in here. Well, there are the intestines again. Those are pretty obvious. And the fan of mesenteric arteries and mesenteric veins. Do you see the hepatic portal system in the chair? Looking at this. So you're looking for the blue, which is the veins. The reds would be the arteries. So here is the seat of the chair. There is the spleen, of course. So yeah, here is the splenic vein, merges with the inferior mesenteric vein. You'll have to remove all, or look at a slide that doesn't have all my ink on it. So the inferior mesenteric vein. And the splenic vein again continues on, merges with the superior mesenteric vein. Those two merge, and then we are left with the hepatic portal vein. Shows the inferior vena cava. That's probably enough. Okay, so practice the blood flow to and from the liver in the hepatic portal system.